Hi everyone, you are watching Math Tech 15. In this video, I am sharing BCA first semester Bangalore University January 2025 question paper discrete structure. The question paper pattern is here, timings 3 hours, maximum marks is here 80 marks, 3 sections, section A, section B and section C. Section A is for 2 marks. You need to answer any 8 of the following. Section B for 6 marks, you need to answer any 4 of the following. And section C for 8 marks, you need to answer any 5 of the following. And I already solved section A and section B. Still you didn't check the videos, means please go and check that one. And I made separate playlist for the BCA first semester. I added so many topics videos also and previous year question papers also. Please go and check that one. And still you didn't subscribe the channel, means please subscribe the channel. And in this video we will solve the section C 8 marks questions. The first question is here, let A equals to 1 2 3 4 6 and let R be the relation on A by A comma B such that A and B belongs to capital A and B is exactly divisible by A. The first we need to first one is write in a roster method. It is in the the set builder form. You need to write in the first roster form, roster method. I wrote the question here already. Okay, I will write it once again here. Solution. What is the A set is here? A set is 1 2 3 4 and 6. What is the condition? B is exactly divisible by A. What is they told? B is exactly divisible by A. Okay. And what is the relation here? What is the relation? How it is? A comma B such that A comma B belongs to A. Okay, both A and B belongs to A and B is exactly divisible by A. So here I will write the relation here. They told here B, you have to write the pair A comma B. Here B is exactly divisible by A. So we will start with the 1. Okay, 1 comma 1. Is it possible? B, 1 divided by 1 is exactly divisible. Okay, next 1 comma 2. So 2 divided by 1 means it is a 2 only. Now see here, 2 divided by 1, it's 2 only. So it's exactly divisible. So 1 comma 3 also come, 1 comma 4 also come, and 1 comma 6 also come. Next, now we will check with the 2. 2 by 2 comma 1, no, it will become 1 by 2. No, it won't come. Next 2 by 2, 2 by 2, 2 by 2 is 1. 2 by 3, no. 2 comma 4, 4 by 2, it is a 2. 4 by 2 is what? It is a 2. So 2 comma 6 also come. Next we start with the 3. 3 comma 3 will come and next 3 comma 6 will come. Next 4 comma 4 and 6 comma 6. Okay, this is in a, we wrote in a roster form. This is only the roster form. The first what they told, write the relation R in the roster form. Next, roster method. Find the domain of the relation R. We need to write the domain of the relation R. What are the domains here? First question, domain of relation R. Which are number you have taken in the first, no? A, that are called domain. 1 we have taken and 2 also we have taken, 3 also taken, 4 also taken, 6 also taken. So 1, 2, 3, 4, 6. All the elements of the set A will comes in the domain. Next, what is the question? Find the range of the relation R. The range of the relation R. The range of relation R. What is the range? Range means B elements. 1 is there, 2 is there, 3 is there, 4 is there, 6 is there. So all are is there. So here also all the set A elements are comes in the range also. So 1, 2, 3, 4, 6. Okay. Next they asked here inverse of the relation R inverse. Inverse of a relation R, that is R inverse. How to write this one? I will write it. Just you have to change A and B. The pair we have to interchange. 1, 1, it will become 1, 1 only. So 1, 2, it will become 2, 1. 1, 3, it will changes as 3, 1. 1, 4, it is a 4, 1. 1, 6, 6, 1. 2, 2, it after interchanging also it will be the same. 2, 4, we have to write 4, 2. 2, 6, it will changes as 6, 2. Next 3, 3 only. 6, 3. 4, 4. And 6, 6. Okay. This is the inverse of the relation R inverse. Hope all of you understood this one. It is asked for 8 marks. It's very simple question. Next question. Next question. Using mathematical induction, prove that 1 plus 2 plus 3 plus n equals to n into n plus 1 divided by 2. We need to prove this formula statement using the mathematical induction. Mathematical induction means we need to remember we have to use the 3 steps. The first one is n equals to 1. That is we need to prove that one n equals to 1. The second the step is we need to assume, only just assume that one n equals to k is 2. And the third step is n equals to k plus 1. That is also first step and the third step we need to prove. Second step just we need to assume that. Okay, now we will do this one. First I will write down the formula once again. What is this statement? 1 plus, you can take as statement, otherwise formula. Okay, we need to prove this one by mathematical induction. This is the formula. The sum of the first natural numbers. Sum of n natural numbers is here n into n plus 1 divided by 2. Okay, this is the formula and it's a helpful formula also. You need to remember this one. Okay, what is the step 1 here? Step 1 is here we need to prove that n equals to 1. P of n, this statement we have to take here, P of n. Okay, P of n for n equals to 1. N equals to 1. First we will take the LHS. What is the LHS? This left hand side, this one. So it is a P of 1. P of 1 means we have to take only first element only. We are taking n equals to 1. 1 means we have to consider only one element. That is 1 only. Okay. Next, RHS. What is the RHS here? N into n plus 1 divided by 2. N into n plus 1 divided by 2. We have to substitute here n equals to 1. 1 plus 1 divided by 2. 1 plus 1 is here 2. 2 divided by 2. It's get cancelled. It's 1 only. Therefore, LHS equals to here RHS. Therefore, P of 1 is here true. Okay. First step we need to prove that. We need to prove here. That is n equals to 1. The second step is only just we need to assume. Step 2. Step 2 is what? Assume the statement P of n is true for n equals to k. Just we are changing the variable here, just n equals to k. That's the reason just we need to assume this one. What is the statement? We have to write here p of k. P of k equals to 1 plus 2 plus k. N changes to k. Right hand side also k plus 1 divided by 2. This is, we will give the equation number 1. Why should we need to give the equation 1 means in the step 3 we are using this equation 1. That's the reason we required this one. That's the reason we have to give this as the equation number 1 because of step 3. Next, step 3. What is step 3? Step 3 we need to prove for n equals to k plus 1. That is, we need to prove. Okay. Step 3, by using the equation 1. Otherwise you can write p of k statement. By using p of k statement, that is equation 1. Okay, that is equation 1. Now we shall prove that p of k plus 1 is also true. Is also true. We need to prove this one by adding. Now see here, in the third step so many students will get confused what we need to add here. By adding what? Okay, just see here, we need to prove here p of k plus 1 is 2. The next term should come. What is the next term? The next term should come here. The last term should come here, k plus 1 only. Because we are proving here p of k plus 1 is 2. We shall prove that here k plus 1 is 2. So next term should be the final in the LHS side, left hand side, the last term should come here k plus 1. So we need to add this one only. We have to check from the left hand side. Suppose if it is, the question is like 1 square plus 2 square, n square is there, then what we need to add here means we have to add what is the next. If it is a k square means the next number should come k plus 1 whole square. So we have to add k plus 1 whole square in that case. If it is cube, 1 cube, 2 cube, 3 cube, k cube means we have to add k plus 1 whole cube. Understood? We have to check from the LHS only. What is the last the term should come. In place of k we have to write just k plus 1. If it is square, you have to take square. It is cube, then it is you have to take cube. If it is 2k means you have to take 2k plus 1 according to that one only. Okay, just in the left hand side, in the statement left hand side, the last number you have to replace with k replace with the k plus 1. That's term only we need to add on both the sides of the equation 1. It's a very simple. Okay, so we have to add here, what we need to add here, k plus 1 on both the sides of equation 1. On both the sides of equation 1. Okay, so many students will get confused this one only. What we need to add, just you substitute the replace the k by k plus 1 in the last term of the LHS. That is only we need to add. Okay, so I will write it here. We have to add here k plus 1 on the on both sides of the equation 1. So 1 plus 2 k, it's a k plus 1. In right hand side also k plus 1 divided by 2. We need to add here k plus 1. Now see students, here left hand side we only by observing the statement, otherwise equation, by observing the equation only we only took this one k plus 1. So it's correct only, not need to do. It's already we only took na k plus 1. It's correct only. 1 plus 2 plus next last term is k plus 1. Because we are truing for k plus 1, p of k plus 1 is only true. So it's already solved only. Now we need to solve this RHS side, right hand side. So we have take the LCM here. 2 is the LCM. k into k plus 1. It is, you have to multiply with 2 here, 2k plus 1. Now we need to solve this one. Left hand side same as it is, 1 plus 2 k plus 1. Now see here, I will write LHS also, 1 plus 2 1 plus 2 k plus 1. Okay, I will open the bracket. K into k is k square plus k, 2k plus k divided by 2. Okay, left hand side same as it is only. I will write only last term and the first term similarly. Now see here, k square, 2k plus k, 2k plus k is 3k, and it is a 2k plus 2, this one, it is a 2. It is a 3k plus 2. Okay, divided by 2. Now we have to split this one. 2. How to split? After multiplication it should come 2 into 1 is 2. After adding it should come 3. So k square, 3k we need to split as 2k plus k. The quadratic equation, we need to, the numerator is in the form of quadratic equation. You have to solve this one. Take k common in the first two terms, k plus 2. In the second two terms, last two terms, you have to take 1 common because nothing is common there. Again k plus 2 is common. So k plus 2, k plus 1 divided by 2. Now see here, left hand side. First I will write here k plus 1, and this is the k plus 2 divided by 2. Left hand side is here 1 plus 2 k plus 1. Now just watch here, we got the same as it is equation. When it is n is there, it is n changes to k plus 1. Here also n changes to k plus 1. It is n equals to k plus 1 plus 1. It is k plus 2. Otherwise you write down like this, k plus 1, k plus 1 plus 1. It is plus 2 only. Okay. Therefore, P of k plus 1 is also true. Hence we proved here. See here, we got same as it is like our statement. K, n equals to k plus 1. Here also n equals to k plus 1 plus 1 divided by 2. Hence it's a proved. Therefore, lastly we have to write this three lines here. Thus P of k plus 1 is true whenever P of k is true, because we took the using P of k statement only. That's the reason whenever P of k is true, then P of k plus 1 is also true. Hence from the principle of mathematical induction, P of n is, the given statement is true for all n is greater than or equals to 1. Okay, we will move to the next question. Okay. The next question is here. Find the eigenvalue and eigenvector of A matrix, that is 2 by 2 matrix they have given. First row is 5 4 and second row is here 1 2. So here find the eigenvalue and the eigenvectors of A. The matrix is here A matrix equals to, the first row is here 5 4, second row is here 1 2. It is a 2 by 2 matrix, it's a square matrix. And remember this one, for the eigenvalue and eigenvector they always ask, they will ask for the square matrix only. Okay, first we need to find out the eigenvalue. For finding the eigenvalue, okay, for finding the eigenvalue, first we need to write the eigenvalue equation. Otherwise you can also call as the characteristics equation also. The eigenvalue equation. What is the eigenvalue equation means? Determinant of A minus lambda I equals to 0. Here lambda is any scalar and I is the identity matrix. Lambda is the scalar. Okay, that is only the eigenvalues. It is only lambda values only. It is only the, it will call as the eigenvalues. Eigenvalues. And I is here identity matrix. Identity matrix. Okay, now see here, our question is, if it is 2 by 2 matrix, then identity matrix also you have to take 2 by 2. If it is, suppose if they ask for the, find the eigenvalue and eigenvector for the 3 by 3 matrix, we have to take the identity matrix also 3 by 3 matrix. According to the A is 2 by 2 matrix, then identity matrix also 2 by 2 matrix only. We need to understand like that. Okay, I will write A matrix here. A is 5, 4, 1, 2 minus lambda. I is here 1, 0, 0, 1. This is the identity matrix. Identity matrix means principal diagonal elements are 1, remaining all are 0, equals to 0. Now we will solve this one. It will come 5 minus lambda. 4 minus 0, it is 4 only. 1 minus lambda. Lambda into 0 is 0 only here. So it is also 1 only. 2 minus lambda equals to 0. Okay, now we need to find out the determinant of this. Determinant. Okay, need to find out the determinant of this. So how to find out determinant? You have to multiply the principal diagonal. 5 minus lambda into 2 minus lambda. It's a determinant. Okay, not matrix. Minus 4 equals to 0. Open the bracket. 5 2s are 10. 5 into minus lambda is 5, minus 5 lambda, minus 2 lambda plus lambda square, minus 4 equals to 0. Lambda square minus 7 lambda. 10 minus 4 means it's a 6 equals to 0. Again it is in the form of quadratic equation. 6 we need to split as a 6 ones are 6. It should come minus 6 minus, because the addition should come here, minus 7. So lambda square minus 7 you have to split as minus 6 lambda minus lambda plus 6 equals to 0. So lambda we need to take here, lambda minus 6 here, minus 1 we have to take common. So it will come lambda minus 6. Here also lambda minus 6 equals to 0. Again lambda minus 6 we have to take common here. So it will come lambda minus 1. So lambda minus 6 equals to 0 and lambda minus 1 equals to 0. So lambda equals to 6 and lambda equals to 1. So the eigenvalues are here. Therefore, I will write it here only. Eigenvalues are lambda equals to 1, 6, 1 and 6. Okay, now we need to find out the eigenvectors. So first I will write the eigenvalues. What we got here, eigenvalues are lambda equals to 1 and 6. Okay, now we need to find out the eigenvectors. Now see here, we have to, for finding eigenvectors compulsory we need to find out eigenvalues. Without finding the eigenvalues we don't, it is not possible to find out the it's not possible to find out eigenvectors. So eigenvector, first one, first eigenvector for lambda equals to 1. Okay, for this equation, eigenvector equation is here. Eigenvector equation, A minus lambda I into V equals to 0. Okay, A minus lambda I, already we got that one. What is that A minus lambda I? That is, I will write it here, 5 minus lambda, 4, 1, it is a 2 minus lambda. This is into V. V means it is a column matrix. It is a vectors, eigenvectors x comma y equals to 0. Okay. Now we took here lambda equals to 1. We will substitute here for lambda equals to 1. So 5 minus 1, 4, 1, 2 minus 1, x, y. So 5 minus 1 means it's a 4, 4, 1, and it's also 2 minus 1 is 1. X by y equals to 0. We need to do the matrix multiplication. First matrix we have to take row wise, and second matrix we have to take by the column wise. Okay, 4 into x is 4x plus 4 into y is 4y equals to 0, and second one it is will come like x plus y. It will come, it is also equals to 0. Now see here, x equals to, suppose since x equals to you have took 1 means it is y is also x equals to minus y. So x, since x equals to you took 1 means y will come here minus 1. Okay, therefore eigen vector v1 equals to 1 by 1 minus 1. Otherwise you have the another one method. How to find out means you got the equation, both will come same only. So here you take the 4 common and send right hand side, that will come become x plus y only. So you have to write like this, x equals to minus y, and what is the denominator of this one? 1 only. So x divided by 1, and you have to take it is a y, this minus and you need to send this side. So it is a 1 and y denominator minus 1. Anything is okay. Or now we will find out the eigenvector for lambda equals to 6. Eigenvector for lambda equals to 6. What is equation? A minus lambda I into V equals to 0. What is A minus lambda I? 5 minus lambda 4, 1 minus 2 minus lambda into V is x column matrix x y. It's a 0 means it is it's like this 0 comma 0. Okay, what is lambda here? Lambda equals to 6. 5 minus 6, 4, 1, 2 minus 6 into x by y 0 comma 0. It's 0. Now see here, 5 minus 6 means it's the it's a 1. Minus 1, 4, 1, 2 minus 6 means it's a minus 4. Minus 1 into x is minus x plus 4y. So 1 into x is x minus 4y equals to 0 comma 0. So we'll get the two equations here. Minus x plus 4y equals to 0, and another one is x minus 4y equals to 0. Both are same only. So x equals to here, my x you need to send this side, it will become 4y. Okay, no coefficient you send this side, x by 4, y by 1. So therefore eigenvector says v2 is here 4 by 1. Now see here, what is the equation we got here? X equals to 4y. You have to substitute x equals to, if you suppose you took the 4, then y will become 1. Just see here. Let x equals to, you took 4, then x by 4 equals to y. So 4 by 4 equals to 1. So otherwise you send the coefficients like this. The denominator, x denominator will come the first, then y denominator comes in second, y value, eigenvectors. Therefore, what are the eigenvalues? Eigenvalues are lambda equals to 1 and 6, and eigenvectors v1 equals to 1 minus 1 and v2 4 1. Okay, hope all of you understood this one. Next questions we will solve in the next video. Still you didn't subscribe the channel means please subscribe the channel and share the videos to your friends. Thank you.